we must be very careful with some kind of special matrices. So let me explain why we may find inaccurate results. Because you see that the coefficient of some terms may be very large. So if you use this method, there might be errors in it. Format long, we may find that there might be errors in the results. For instance, for this term, you may find that it might be something here we have 4. We may expect some terms like that. And if you use Pauli 1 function, you may get accurate results. Because in the algorithm we use, we only need to perform multiplications for summation of 2 matrices. So there isn't too much result. Even on our precision algorithm, we can still get very accurate results. So that is why we get the error matrix as a 0 matrix. And in this example, we need to say, what we need to say is we have to use Pauli 1 function rather than the Pauli function. And also, I think the better way to change it is to change the function Pauli 1 function to the Pauli function. And Matlab can have priority to code this function to supply to the original Pauli function. Now let's see, there are 2 kinds of matrices that I already said. There are 2 kinds of matrices. One is a symbolic matrix, and the other one is a numerical matrix. And if I have been given one matrix, how can I convert the matrix into another form? For instance, if I have already a double precision matrix, then what I need to do is to throw a Pauli 2 thing function to convert it into a symbolic variable. Or if we have a symbolic variable, we can use thing to Pauli to convert it into a double precision polynomial. So we can use this kind of command to convert between the 2 kinds of polynomials. So now let's start another topic. The inverse matrix. The definitions first, and then we will extend the ideas to generalized inverse of a matrix. If we have been given the matrix A, what is the inverse of the matrix? In theory, if there exists a C matrix which satisfies this formula, then we say that C is the inverse matrix of A. And it is mathematically denoted like this. And also, as assumption, the matrix A, if we are talking about the inverse matrix, it must be a square matrix. And if the square matrix is non-singular matrix, then we say that it will have an inverse, and the inverse is denoted like this. And in mathematics, in algebra, I think you have already learned many ways to find the inverse of the matrix. For instance, if you can have a matrix A here, and you can append it with an identity matrix, and then by elementary transformation to the matrix, you can convert this one to a diagonal element, the identity matrix, and this part will be the inverse matrix. I'm not sure whether you remember this kind of way to find the inverse of matrix. But that's not important. What you need to do is, if you want to solve this problem by Matlab, you can code the IMD function, and you will find the inverse of the function immediately. Suppose there is a 4x4 Hilbert matrix. We can use this command to generate the 4x4 Hilbert matrix. And then we can use this command to find the inverse of the matrix. So now the question is whether the inverse matrix is correct or not. We have to validate the result. How can we validate the result? If we multiply H1 by H, it should be an identity matrix. So we can take the error here. H times H1 minus the identity matrix, this should be the error. So we can find the norm of it. First, we can find what is the inverse